So, OpenAI just dropped their most capable frontier model yet, GPT-5.4, and I spent time reading every single word of the official announcement, pulling every number and leaderboard to understand exactly where this model stands in the real competitive landscape. According to OpenAI, GPT-5.4 is a different kind of product entirely, and the numbers that prove that are buried in the technical details that most people skip. Now, I am going to show you all of them. So, without wasting time, let's jump right in. GPT-5.4 launched on March 5th. OpenAI describes it as their most capable and efficient frontier model for professional work. There are mainly 4 things they are leading with. Number 1, state-of-the-art coding. Number 2, computer use, meaning the model can operate a real computer with a browser and real websites. Number 3, Tool search, a new way the model handles large numbers of tools that changes the economics of building AI agents. Number 4, a 1 million token context window. That is the official package, but the headline numbers are only part of the story. By the end of this video, you're going to understand not just what GPT 5.4 can do, but exactly where it fits in the competitive landscape, what it still cannot do, and whether it is worth switching to for your workflow. Let me start with the number that OpenAI is most proud of, because when they say GPT 5.4 is their most capable model for professional work, they have a specific benchmark backing that up, as it is called GDPval. GDPval tests AI models on the actual work that professionals do in their jobs every day. Presentations, spreadsheets, financial models, research memos, legal documents, the kind of output a real human professional would hand to their manager on a Friday afternoon. The tasks span 44 occupations from the top 9 industries contributing to the U.S. economy. Everything from investment banking analysts to registered nurses to software developers to college professors. And human expert judges evaluate whether the AI output matches or exceeds what a top industry professional would produce. Here is what GPT 5.4 scored: 83%. That means GPT 5.4 matched or exceeded professional level output in 83 out of every 100 comparisons. Now let me give you the context to understand why that number matters. When GPT 5.2 launched back in December, it scored 70.9% on GDPval. That was already a big deal. It was the first time any AI model had crossed the threshold of performing at or above expert level, and people lost their minds over it. GPT 5.4 just added 12 percentage points on top of that, 70.9 to 83. That is not a small iteration. That is a meaningful jump in what this model can produce when you give it a professional task. Here's the other thing about GDPval that matters. When GPT 5.2 came out, one of the human judges evaluating outputs wrote a comment. They said the output appeared to have been done by a professional company with staff with a surprisingly well-designed layout, and that was the reaction to 71% performance. GPT 5.4 just pushed that number to 83. Now this one is for developers and anyone using the model to analyze images, documents, or screenshots. GPT 5.4 introduces something called the original image input detail level. Before GPT 5.4, the high detail level supported images up to 2.56 million total pixels, or a 2048 pixel maximum dimension. That was already more than enough for most everyday images. With GPT 5.4, the original detail level now supports up to 10.24 million total pixels and a maximum dimension of 6,000 pixels. To put that in plain English, GPT 5.4 can now see a full resolution photo or document and process every pixel in it. But why does this matter? Think about the kinds of images where pixel level detail actually matters: dense spreadsheets, architectural drawings, medical scans, dense legal documents, or high-resolution photographs. OpenAI says they observed strong gains in 3 specific areas: localization ability, image understanding, and click accuracy when using original or high detail during early testing with API users. Now, I want to spend real time on this one because this is the demonstration that stopped me when I read the announcement. Computer use means GPT 5.4 can operate a browser like a human does, can see a screen, understand what is on it, decide what to click, fill in form fields, navigate between pages, and complete multi-step tasks on real websites. The model's performance and flexibility are reflected across benchmarks that test computer use across different settings. On OSWorld Verified, which measures a model's ability to navigate a desktop environment through screenshots and keyboard/mouse actions, GPT 5.4 achieves a state-of-the-art 75.0% success rate rate far exceeding GPT-5.2's 47.3% and surpassing human performance at 72.4%. And on WebArena Verified, which tests browser use, GPT-5.4 achieves a leading 67.3% success rate when using both DOM and screenshot-driven interaction, compared to GPT-5.2's 65.4%. On Online Mind 2 Web, which also tests browser use, GPT-5.4 achieves a 92.8% success rate using screenshot-based observations alone, improving over ChatGPT Atlas Agent Mode, which achieves a success rate of 70.9%. But OpenAI did not just show it in a demo with one clean website built specifically to make the AI look good. According to Dodd Fraser, CEO at Mainstay, they ran it on approximately 30,000 HOA and property tax portals and websites, the kind of websites that even experienced humans find frustrating. But GPT-5.4 achieved a 95% success rate on the first attempt, 100% success rate within 3 attempts. With prior computer use models, the success rate was somewhere between 73 and 79%. That gap from 73% to 95% is the difference between a tool you can occasionally use and a tool you can actually deploy in production. GPT-5.4 completed these sessions approximately 3 times faster than prior models, and it used approximately 70% fewer tokens per session, 3 times faster, 70% cheaper to run, higher accuracy, all at the same time. With original resolution input, GPT-5.4 can see that interface with far more precision than any prior model. The click accuracy improvement in early API testing is part of why the success rate jumped so dramatically. As you can see here, this is an example of computer use where GPT-5.4 processes a list of records and submits the information across 10 web forms using Playwright-based browser automation. And GPT-5.4 also interprets screenshots of a browser interface and interacts with UI elements through coordinate-based clicking to send emails and schedule a calendar event. Now let us talk about tool search. When you build an AI agent with many tools, say tools for searching the web, making API calls, sending messages, you have to tell the model what tools it has access to. If you have a complex agent with 50 tools, all 50 tool definitions went into every single request. That means thousands of extra tokens, sometimes tens of thousands of extra tokens added to every single request, even if the model was only going to use 2 or 3 tools for that particular task. Now, GPT-5.4 introduces tool search to fix this. Here's how it works. Instead of injecting all tool definitions into the prompt upfront, GPT-5.4 receives a lightweight list of available tools. When the model needs to use a tool, it looks up that tool's definition on demand. It appends it to the conversation at that moment, and only then does it actually call the tool. The result is fewer tokens required for tool-heavy workflows. Cache is preserved, which matters a lot for cost reduction on repeated similar requests, and the model can now reliably work with much larger tool ecosystems than before. Here is an example of token savings from tool search. Nearly half of tokens are saved with tool search. You could give an agent access to hundreds of tools, a full suite of enterprise integrations, without paying the performance or cost penalty of loading all of them into every request. Now let us talk about coding. GPT-5.4 is positioned as a state-of-the-art coding model. So how does it actually benchmark on SWE-Bench Pro? The standard coding benchmark, GPT-5.4 scores 57.7%. So it matches or outperforms GPT-5.3 codecs on SWE-Bench Pro while being lower latency across reasoning efforts. Not at the absolute top of the leaderboard, but competitive with the best models out there. They also released an experimental codec skill called Playwright. This allows codecs to visually debug web and Electron apps. It can even be used to test an app it is building as it is building it. Here's an example. Theme park simulation game made with GPT-5.4 from a single, lightly specified prompt using Playwright Interactive. The simulation includes tile-based path placement, ride and scenery construction, guest pathfinding, queuing, and ride cycles, while park metrics like money, guest count, happiness, cleanliness, and rating rise or fall based on how the layout performs and how guests respond to it. Playwright was used to automate browser playtests by building and expanding the park, placing and removing paths and attractions, checking camera navigation, and verifying that guests, queues, ride states, and UI metrics updated correctly over several rounds of play. And another tactical RPG game created iterated with GPT 5.4 over multiple turns, using Playwright Interactive for browser playtesting and image generation for the game's visual style, characters, and thematic asset set. The game features turn-based combat on a grid map, with systems for movement, actions, positioning, and encounter flow, alongside a presentation layer refined through iterative UI and shader work. Image generation was used to create characters, and Playwright was used to validate the interface, inspect and refine UI behavior, and support iterative edits as the game's combat, visuals, and overall feel were tuned over multiple rounds. GPT 5.4's combination of better computer use, original resolution vision for reading code and diffs, and improved reasoning makes it stronger on complex multi-step tasks. Now let me check an independent leaderboard, because benchmark numbers from the company that built the model are one thing. Independent third-party evaluations are another. The Mercor Apex Agents Leaderboard evaluates AI agents on actual professional work, real day-to-day tasks from 3 specific jobs: investment banking analysts, management consultants, and corporate lawyers. 480 tasks, 33 worlds, real work products evaluated against real grading rubrics designed by actual experts. Here's what the current leaderboard shows. Overall, across all 3 jobs combined, GPT 5.4 at the top with 35.9% performs better than Gemini 3.1 Pro 33.5% and Claude Opus 4.6 31.7%. GPT 5.4 Thinking gets 2 upgrades that are worth understanding. First, for longer, more complex queries, the model will now outline its work with a preamble before diving in. Starts by outlining its approach before working so you can see the plan before the execution. GPT 5.4 brings that behavior to thinking mode for non-coding tasks as well. Means you can see where the model is going before it gets there. You can redirect it mid-response if it is going in the wrong direction. You do not have to wait for a wrong answer and then start over. Second upgrade, GPT 5.4. Thinking can now think longer on difficult tasks while maintaining stronger awareness of earlier steps in the conversation. The thinking mode update is available right now on ChatGPT.com and on Android. It is coming soon to the iOS app. Now let me show you something that the headline GPT 5.4 numbers do not tell you. Go to arcprize.org and look at the ARC-AGI leaderboard. ARC-AGI-2 is a benchmark designed to measure the ability to identify patterns and reason about new problems the model has never seen before, the kind of reasoning that humans do easily, but that AI systems have historically struggled with. Here is where the best models currently stand on ARC-AGI-2. GPT 5.4 scores 83.3%, just behind Google Gemini DeepThink at 84.6%, and the average human performance on these tasks is approximately 53%. So GPT 5.4 is very impressive because the ARC Prize leaderboard is the most honest window into that AI race. GPT 5.4 comes with a 1 million token context window. To put that in perspective, GPT 5.2 had a 256,000 token context window. GPT 5.4 is roughly 4 times larger. 1 million tokens is approximately 750,000 words. That is a full-length novel, a complete codebase, an entire research archive, all in context at once. For agentic use cases, where the model needs to maintain context across many tool calls and long-running tasks, this is one of the most practically important spec upgrades in this release. GPT 5.4 is also better at Agentic Web Search on BrowseComp, a measurement of how well AI agents can persistently browse the web to find hard-to-locate information. GPT 5.4 leaps 17% over GPT 5.2, and GPT 5.4 Pro sets a new state-of-the-art at 89.3%. In practice, this means GPT 5.4 thinking is stronger at answering questions that require pulling together information from many sources on the web. It can more persistently search across multiple rounds to identify the most relevant sources. Now let us talk about availability. GPT 5.4 is available in ChatGPT for paid subscribers. GPT 5.4 thinking is available for ChatGPT Plus, Team, and Pro users, replacing GPT 5.2 thinking. GPT 5.2 thinking will remain available for 3 months for paid users, then it will be retired on June 5th, 2026. GPT 5.4 Pro is available to Pro and Enterprise plans. It is also available through the API. For the full API pricing details, including input and output token costs, here's a complete chart. So here is a complete review of GPT 5.4. The gap between what this model can do and what was possible 12 months ago is enormous. The links to the GPT 5.4 announcement, the Mercor Apex Agents Leaderboard and the ARC Prize Leaderboard are all in the description. Go look at the numbers yourself, form your own opinion. Drop it in the comments. I read them all. And do not forget to like, share, and subscribe. Thanks for watching, and I will see you in the next one.